Here we have the Laplace transformation. We're going to do one other one with Fouriers and one other one with both of them combined, maybe. That one's a maybe. Um, so we have our differential equation. We expand out our y of double omega by using our properties that we have shown. The first property that I'm going to drag out, which is in your table probably, is going to be this one up over here. As you know, if you look at this, last time we talked about how higher patterns agree with the lower patterns over here, where we have this type of pattern coming along, which is basically saying that once you figure out you have a differential equation, you can see it as a minus the initial condition of that first f of x times the order of the power of the derivative. So the derivative power goes here, and so on and so forth. And then a lot of the initial condition can multiply by s or so on, s squared, depending on the order. Anyways, we move on to over here next. That's the first step. We drag it out like this because of that. And now we move this to this format, which is just doing a simple Laplace over here. Simplifying gets you this kind of format over here. And doing some algebra, you get this. And then partial decomposition happens, where you're left with this format. And then you do the inverse, which is done by looking at the table again. I'm going to make the table later on. I actually just forgot to make the table before this whole thing. Anyways, so with that said, you look at this, it says that is the same as exponential over here. If you look at the exponential, which is up all the way over here, the over here is the same thing, just a different constant. And you go over here to the sine and cosine, and you see that it is just the same thing again, sine and cosine again and again. That's why we get the inverse correlation, because it's a one-to-one, we can say this is true. Now, a lot of times I know that there has to be a unit step function, but a lot of times because of how information in math works, you actually can get rid of this, and most likely, most of the time, the information follow backwards too, unless special cases happen, which is why I still have to put the unit step over there. But that's it, and I'm gonna stop the recording.